All right, let's get started with surface area of prisms and cylinders, section 12.2. All right, our lesson objectives: find the lateral areas and surface areas of right prisms and the right cylinders, and use these areas of right prisms and right cylinders. Our essential question: how can you find the surface area of a prism or a cylinder? All right, let's start by defining some key vocabulary. You've got your lateral faces. That's going to be all the sides of your solid. They're the parallelogram faces or sides formed by connecting the corresponding vertices of the bases. So if I connect this vertex to this vertex to this vertex, then I've got a lateral face that's a parallelogram. Your lateral edges, these are the segments connecting the vertices of the bases. So this is your lateral edge, lateral edge, lateral edge. In this case, we have 6 lateral edges. Surface area is the sum of all the areas of the polyhedron's faces, so add every face together, the area of every face. And then lateral area is just the side pieces that are added up together. All right, continue with our vocabulary. We have a net, which you might be familiar with. It's a 2-dimensional representation of the faces of a polyhedron unfolded. You always have your bases on opposite sides of your lateral faces, and your lateral faces of a prism will always be rectangles. Lateral faces of pyramids will always be triangles. You have your right prism. It's each lateral edge is perpendicular to both bases. So this would be an example of a right rectangular prism. Got perpendicular to the base. Height is perpendicular as well. Your oblique prism, it's a prism with lateral edges that are not perpendicular to the base. So notice how it kind of goes at a slant. These are your lateral edges, and they're going to go in a slant. But the height still remains perpendicular to the base. All right, one of our first core concepts, key vocabulary and key formulas. So for lateral area and surface area of a right prism, we need to know all of our parts. So all these letters mean something, so let's get that in our notes. Perimeter is capital P, the base apothem is lowercase a, height h is always for the solid, base area capital B, lateral area capital L, surface area capital S. Your textbook and your formula chart have 2 different sets of formulas. Both work fine. One thing that might be confusing on the formula chart is the lateral area and the surface area both have the same letter, S, capital S. So I'm fine if you change it to capital L for lateral area, capital S for surface area. And then our lateral area formula on the right side of the equal sign matches for both the textbook and the formula chart. And the surface area, total surface area, is a little bit different, but as long as you know what all the letters mean, then both formulas make sense and either work. All right, so let's try the new formulas on this pentagonal prism. Let's start by identifying the 2 formulas we're going to need to use. So we have our lateral surface area, which is going to be the perimeter of the base times the height of the solid. And then we need total surface area, which means we need the apothem times the perimeter of the base plus lateral surface area. So that means we need to calculate some parts. So sketch your triangle sector that is going to be that's going to come from the pentagon, or sorry, the pentagon, and that's going to be these lengths. So you've got 6 feet for each of the radii. Altitude is always your apothem, and then half of the side 7.05, so 3.525. So that you can figure out your apothem, which is going to be determined by using Pythagorean theorem. So we get 6 squared minus the 3.525 squared underneath the radical. So it comes out to be this value under the radical, which you can keep it as is, because you'll just substitute that into your formula over here. Then we want perimeter of our base, so we need capital P's in both formulas. So that's going to be 5 times each side length 7.05, getting you a total perimeter of the base 35.25. All right, so we'll plug into our lateral surface area the numbers we need, getting us 317.25 feet squared. And then substitute all of our numbers that we know for the next formula. So lowercase a is the apothem, and we figured that out over here. So substitute the whole thing that you got under the radical, all those values under the radical, times the perimeter of the base, which is figured out by 35.25, plus your lateral surface area, which was 317.25. So you get a lateral surface area, sorry, total surface area of about 488.40 feet squared. So the lateral area is about 317.25 square feet, and the surface area is about 488.40 square feet. All right, let's move on to our cylinders. So finding lateral and total surface area of cylinders. First, let's get some terminology. Right cylinder, similar to the right prism, is the segment joining the centers of bases perpendicular to the bases. So a right cylinder, its center portion here joining the two bases is always going to be perpendicular to the bases. Height, therefore, is perpendicular along the edge of the cylinder. And then oblique cylinders, they're the ones that kind of look crooked. So they kind of go at a diagonal. Essentially, the segment that joins the centers is not perpendicular, but notice once again that the height must be perpendicular to your base. All right, similar to the prisms, you've got special formulas for lateral and surface area of a right cylinder. A lot of this is going to be similar parts, so always when you're dealing with cylinders that have circles, then you're dealing with the radius. So you've got the radius R, height H, that's height of the cylinder, base area capital B, lateral area capital L, once again, surface area being capital S. Textbook formulas look different than the formula chart. Not to be confused, they both work fine. So for lateral surface area, you want to take 2 pi r, which remember is your circumference. So if you're getting the circumference of the circle base, that's going to be the same length as this side edge of the rectangle. So if you were to roll this circle out flat, it would be this length of the rectangle times the height. So that'll get you your lateral area. And then for total, you add in the area of the bases. All right, so let's use this formula to find the areas of the cylinder here. So start by writing your formula. First step. Second step, substitution. You want to substitute 4 for your radius, because that's given, and then 8 for the height of the cylinder, also given. So your exact answer would be 64 pi meters squared. You type that in the calculator, it's approximately 201.06 meters squared. All right, next to find the total surface area, you would find the area of both your bases and then add it to the lateral surface area we just figured out. Okay, so you'd plug in the 4 for the radius, and then 64 pi. Always use exact for new formulas. Substitute exact, and then always use exact rounding at the end. So 96 pi meters squared. Adding that together to be 96 pi exact meters squared. Type in the calculator, get 301.59 meters squared. All right, let's take a look at designing a label for a cylinder soup can, which means the label is just going to be on the outer side, the lateral area. So what would be the minimum amount of material needed for the label? Let's start by finding the radius. And the radius is half the diameter, which is 9. Divided by 2 would be 4.5, and that's centimeters. Next, we would want to find the lateral surface area. So lateral surface area is 2 times pi times radius, height of cylinder. So next you would substitute your values, 4.5 in place of r and 12 in place of h. Exact would be 108 pi. And typing 108 pi in the calculator gets you 339.29 centimeters squared. So you need a minimum of about 339.29 square centimeters of materials. All right, let's solve another real-world problem using surface areas of right prisms and right cylinders. So now we're going to do a compound solid here with 2 different solids that we have to figure out. So let's start by thinking about what parts we need to figure out in order to get the surface area and lateral area of our solids. So we know that to get lateral area of our solid, we need the lateral area of the cylinder, so that's this outside part, and the lateral area of the prism, which is the hole that appears to be created in the middle of the cylinder. All right, so looking at these two different formulas, so the formula for the lateral area of a cylinder is 2 pi r times the height of the cylinder, and then to get lateral area of the prism, it's the perimeter of the base times the height of the prism. So we substitute the values we know. We know radius is 6. That's defined right here in our picture. We know that the height of the cylinder is 12. 14 is our perimeter for the rectangular prism. So it's 4 plus 4, that's 8, plus 3 plus 3, that's 14. And then the height of the prism is also 12. It's the same height of the cylinder. So exact answer and lateral area of the entire solid would be 144 pi plus 168. Type that in the calculator, get approximate lateral solid area. All right, just added the units so that you could see those correctly identified. All right, so next we want to take a look at, if we want the surface area of the entire solid, we need the lateral area of the solid plus 2 times, and there's an open parentheses because on the inside here we need to get the area of the base of the cylinder minus the area of the base of the prism. So you have multiple formulas that you have to consider here. The lateral area of the solid, we already figured out to be 144 pi plus 168. Anytime you're doing new calculations, you always want to use exact, and then you always round at the very, very, very end of the entire set of calculations. So that's why pi is continuing to remain in your substitutions for this next step. So then over here, we just need to identify the two areas we would use for area of base of the cylinder. So that's going to be pi r squared. Area of the base of the prism is going to be length times width. So we're subtracting the area of the circle, pi r squared, minus length times width. And we already know those values. For radius, it's 6. For length, it's 4. For the width, it's 3. All right, so our exact surface area of the solid, total surface area would be 216 pi plus 144 meters squared. Typed in the calculator, approximately 822.58 meters squared. All right, and the last thing we want to talk about is changing the dimensions and how it affects the surface area of a cylinder. So let's just double all the linear dimensions and see what the effects are. So do your before change. That means create your chart. You have your before change and your after change. So we're starting with dimensions, radius 2 feet, height of the cylinder 8 feet. Plug into your formula. Either formula works. 2 pi r squared plus 2 pi r h. Worked out to be exactly 40 pi. Now let's see what happens when I double all my dimensions. So now I have a radius of 4 and a height of 16. So we plug in, and looks like now my new surface area is 160 pi feet squared. So what's the effect? So compare the 40 pi to the 160 pi. How much more area after we doubled all linear dimensions? So it looks like doubling the linear dimensions results in a surface area that is, and you would divide the new by the original. So the pi's divide out to be 1s, and so 160 divided by 40 is 4, which is the same as 2 squared. Remember, our original was doubling the linear dimensions, and we had 2 dimensions change. So we squared the original, that got us the 4, times the original surface area. All right, we're going to start having some fun with these solids now. All right, bring any clarifying questions and get ready to practice these skills in tomorrow's lesson. See you then.